Sea level rise is no longer a distant environmental concern discussed only in scientific journals or international climate summits. It is now one of the most visible and measurable signs of a warming planet, unfolding in real time across coastlines, island nations, and major cities around the world. Scientists have warned for decades that global warming would eventually reshape Earth's oceans, but new research shows the process is happening faster than previously understood. More importantly, researchers now say they can clearly explain why sea levels are rising, how different forces contribute to the problem, and why the trend is expected to continue for centuries. A major international study published in Science Advances has now solved one of climate science's most persistent mysteries: the gap between observed sea level rise and the estimated contributions from known causes such as ocean warming and melting ice. Using improved satellite technology, refined climate models, and more accurate measurements of glacier and ice sheet loss, scientists say they can now account for almost the entire rise in global sea levels over the past 6 decades. The findings offer both scientific clarity and a stark warning. Earth's oceans are rising at an accelerating pace, driven primarily by human-caused climate change, and the forces behind that rise are becoming stronger with each passing decade. For coastal communities, governments, and billions of people living near the ocean, the implications are enormous. Sea level rise occurs when the volume of the world's oceans increases. Scientists have long identified 2 main reasons for this process. First, ocean water expands as it warms, a phenomenon known as thermal expansion. Second, glacier and massive ice sheets melt and release additional water into the oceans. Both processes are directly linked to rising global temperatures caused by greenhouse gas emissions from human activities such as burning fossil fuels, industrial pollution, and deforestation. According to the new research, global sea levels have risen at an average rate of 2.06 millimeters per year since 1960. While that figure may sound small, scientists emphasize that even slight increases in sea level can have dramatic consequences over time. More importantly, the pace is no longer steady. Between 2005 and 2023, the rate nearly doubled to 3.94 millimeters per year. That acceleration is one of the clearest signs that climate change is intensifying. Researchers found that warming oceans account for the largest share of the increase, contributing approximately 43% of total sea level rise since 1960. As seawater absorbs heat from the atmosphere, the molecules spread farther apart, causing the water to expand. Because the oceans absorb more than 90% of the excess heat trapped by greenhouse gases, this thermal expansion has become a major driver of rising seas. The process may seem simple, but its effects are enormous on a planetary scale. Even small temperature increases across the vast global oceans translate into trillions of tons of expanded seawater. Scientists note that the oceans act like a giant heat reservoir, slowly accumulating energy over time. Unlike air temperatures, which can fluctuate rapidly, ocean temperatures change more gradually, meaning the warming effect continues for decades even if emissions are reduced. The study also highlights the growing role of melting ice. Mountain glacier contributed approximately 27% of sea level rise since 1960. These glacier, found in regions such as the Himalayas, the Alps, Alaska, and South America, have been shrinking rapidly as temperatures climb. Many smaller glacier are already losing mass at alarming rates, and some may disappear entirely within the next century. Meanwhile, the Greenland ice sheet contributed 15% of global sea level rise, while Antarctica added another 12%. Although these percentages are smaller than thermal expansion, scientists warn they are becoming increasingly important because ice sheet melting is accelerating rapidly. Greenland, in particular, has experienced dramatic warming over recent decades. Higher air temperatures cause surface melting during summer months, while warmer ocean waters attack glacier from below. Massive chunks of ice break off into the sea, a process known as calving, further increasing ice loss. Antarctica presents an even more concerning long-term threat. The continent holds enough ice to raise global sea levels by tens of meters if fully melted. Scientists do not expect complete melting anytime soon, but some Antarctic glacier are already showing signs of instability. Warm ocean currents are eroding ice shelves that normally help slow the movement of inland glacier. If these protective barriers weaken significantly, ice flow into the ocean could accelerate dramatically. Between 1960 and the early 1990s, ocean warming and changes in landwater storage were among the dominant drivers. However, since 1993, the rapid melting of glacier and polar ice sheets has become a much larger factor in accelerating sea level rise. Scientists say this shift reflects the intensifying effects of global warming. Early climate change primarily heated the oceans, causing expansion. But as atmospheric temperatures continued climbing, ice loss began accelerating across mountain regions and polar areas. This transition matters because melting ice can potentially produce much larger and faster sea level increases than thermal expansion alone. For years, climate researchers faced a puzzling problem. Measurements from satellites and coastal tide gauges consistently showed more sea level rise than scientists could fully explain using estimates of ocean warming and melting ice. The mismatch was relatively small, but it created uncertainty about whether some important processes were missing from climate models. The new study appears to solve that mystery. Researchers used improved observational tools, updated satellite corrections, and more advanced methods for tracking land movement near coastal measuring stations. They also refined estimates of glacier and ice sheet mass loss using better remote sensing technologies. Professor John Abraham of the University of St. Thomas, one of the study's co-authors, said the work significantly strengthens scientific confidence in sea level measurements. For years, there has been a frustrating gap between how much the oceans were observed to be rising and how much we could explain from the individual causes, Abraham explained. This work shows that, with better instruments, processes, and smarter analysis, this knowledge gap can be closed. We can explain sea level rise with greater confidence. The international research team was led by scientists from the Institute of Atmospheric Physics at the Chinese Academy of Sciences. Collaborators also included researchers from Tulane University, the NSF National Center for Atmospheric Research, the University of St. Thomas, and scientific partners in France. The scientists credited several key advances for resolving the discrepancy. One major improvement involved satellite calibration. Some satellite measurements had gradually drifted after 2015, creating subtle inaccuracies in long-term sea level estimates. The study also reinforces the importance of reducing greenhouse gas emissions as quickly as possible. Although sea level rise cannot be stopped immediately, limiting future warming can significantly reduce the severity of long-term impacts. Low emissions would slow ocean warming, reduce glacier melt, and decrease the risk of catastrophic ice sheet instability. Climate scientists stress that every fraction of a degree matters. The difference between 1.5 degrees Celsius and 2 degrees Celsius of global warming may determine whether certain ice sheets remain relatively stable or begin irreversible collapse. Even modest reductions in future sea level rise could protect millions of people and save trillions of dollars in adaptation costs. Governments around the world are increasingly incorporating sea level projections into urban planning, disaster preparedness, and climate policy. Coastal defenses are being strengthened in some cities, while others are developing long-term relocation strategies. However, experts warn that adaptation alone will not be enough if emissions continue rising rapidly. The study's findings provide stronger scientific certainty about the causes of sea level rise, but they also underline the urgency of global climate action. Scientists now have greater confidence in both the measurements and the mechanisms driving rising oceans. That improved understanding is critical for forecasting future changes more accurately. Reliable projections help governments design infrastructure, prepare evacuation plans, protect freshwater resources, and guide economic investments. Better data also improves public awareness by showing that sea level rise is not a distant theoretical issue but a measurable physical process already underway. The accelerating rise of Earth's oceans reflects the cumulative impact of decades of greenhouse gas emissions. The warming atmosphere, expanding seas, and melting ice sheets are all interconnected parts of the same planetary system responding to human activity. For many scientists, the new research represents an important milestone in climate science because it closes a major gap in understanding. The oceans are rising faster than ever before, the causes are now unmistakably clear, and the process is likely to continue long into the future. Humanity may still influence how severe the changes become, but the era of stable sea levels that shaped modern civilization is already beginning to fade.